Hello everyone, and this is the first Maddox Labs programming video uh, where I'm going to talk about ambient occlusion for this one and how it works, and maybe to help you implement your own ambient occlusion. Here you can see some terrain. I've rendered a simple terrain, and this has ambient occlusion turned on. And why would you to implement this? Well, here it is without ambient occlusion. This is just the diffuse and ambient light, and it doesn't look as good. Ambient occlusion adds all the nice shadowing to give more texture, more detail. And yeah, this is without any texture. So we still have to do texturing on the terrain, which would make it look better. And this ambient occlusion, it's adding the shadow. You can see what the ambient occlusion is, augmenting the light with this kind of a shadow map, which calculates how much ambient light's hitting the different spots in the terrain. And it calculates that by ray casting, and here are the rays that it's casting at each spot. Reds intersect the terrain, and the more rays that are red, the less ambient light is hitting that spot. So as I run around, you can see in the light spots, there's more blue rays, and in the dark spots, like up here, there's more red ones, because there's a lot of occluded ambient light there, so it's darker. And so what you want to do is ray cast a bunch of rays out in a uniform spread around each point, and just get a percentage how many intersect and didn't, and decrease the light in that area according to ratio. And you can turn on all the lights again, so you can see the effect. This is a dumbed down terrain because ambient occlusion is not usually interactive, and it can be really slow. So I had to dumb it down to make it interactive enough to show you. So you can change the number of rays. If I decrease the rays, it still works, but it just becomes very rough and patchy. So you want to have a good number of rays. And what you do is just, for each spot in your terrain, you just step along each of the rays. This is a height map terrain, so just take the map to see if there's an intersection, and just step along each one and add up intersections. So that can take a long time. If I increase it to more rays, you can see how long it takes. It's still not done yet. And there it's done. And it wasn't a huge difference. It got a bit smoother, so you don't want a huge amount. I think what I had was plenty. And you can also change the length of the rays. And longer is better, but also means there's more chance of an intersection with a longer ray. Is it going? Yeah, it takes longer to do this as well. So with longer rays, it's the gradients are better, but it takes a long time. I'm not going to do much longer rays because it will take a long time. And with shorter rays, it works also. It just depends what kind of lighting level that you prefer. And that's it. So ambient occlusion is not done interactively usually. It's done when you create the vertex buffer or you create your pre-processing the asset. This is not screen space ambient occlusion, which is different. Again, that's usually done in a post-process shader for each frame, which this is not. This is just ambient occlusion. And yeah, I'll put up a link to this. The algorithm to generate these rays is I didn't make it up. It's a well-known algorithm called the golden spiral that will generate even distribution of rays. And hopefully that explains ambient occlusion and helps you out in your own implementation.